In terms of future analysis, you don't want to be like tipping your sample out and half your analysis be like some random sellotape.
You're listening to The Cosmic Cast.
Hello and welcome to another episode of The Cosmic Cast, brought to you from the Earth and Solar System team here at the University of Manchester. I'm John Penney-Fisher and I'm joined with the usual co-hosts of Marissa Lowe and Peter McArdle. How's it going?
Hello.
Hey. And this week, back once again appearing on the podcast. We were just chatting about how many times you've appeared now, Sam. It's Dr. Sam Bell. A big warm welcome returning to the Cosmic Cast.
Thank you.
Yeah, we just say it must be 3 or 4 times you've been on in the past. So thank you very much for coming back on again.
Pleasure.
And
this is the first time that we officially can call you Dr. Sam Bell.
Indeed.
That's true. Yeah.
A couple of weeks ago.
Yeah, that's exciting. Yeah, I didn't think about that, but yeah, that's pretty cool.
You don't get special treatment, unfortunately.
Oh.
I don't think. Do we have a special doctor's fanfare?
No, there's no special treatment. But no, Sam, I mean, you've been working. We've invited you on this week because you've been working on a really cool sounding project that we were just saying beforehand we don't really know much about. So the UK has got this suite of Russian lunar rocks from the Lunar up it's really confusing, isn't it? So the Russian Lunar with an A missions, which sounds a lot like Lunar, and it gets very confusing, doesn't it?
Yeah, Lunar without the R, which is always trips me up when I'm writing it. But so the UK, or more specifically the Royal Society, got gifted, in essence, what are like more commonly known for the Apollo samples, when they gave out the goodwill samples to different countries around the world to study like the what was then the Soviet Academy of Sciences. Mm-hmm. Did the same. So they gave out, I think it was about 5 countries in total got given these gifts, or the institutions in 5 of these countries got given these gifts, and the UK and the Royal Society got some samples. Yeah,
and I guess for context then, so that these Soviet missions, these are the only other, apart from the modern Chinese missions, the only other sample return that we have. And I guess they're quite different from Apollo, aren't they, in terms of where they sampled, and I guess it was all robotic, wasn't it?
Yeah, so the 3 robotic missions that picked up the samples all were down sort of like the eastern side of the moon, which is different in terms of the Apollo missions, which are more clustered towards the center of the near side. So yeah, sampled different area, robotically sampled as opposed to collected by humans. And there's these 3 different missions, each 2 sampling sort of Mare, and then another mission sampling some more Highlands material.
Yeah.
So to put this into context in terms of time, there was about 20 odd different lunar missions, weren't there? LNA missions, and were they around the 50s, 60s? So similar time to Apollo, but
yeah, I think they started 1959 maybe, and then ran until Lunar 24 was in 1976, so I think maybe a couple of years after that there was still a lunar program, and I know Roscosmos is sort of like future missions that are sort of reviving the fact that they were called like Lunar, so they're going to carry on with the numbering system. I think.
Yeah. So the ones we're talking about there, was it Lunar 20, 22, 16?
24, yeah.
Okay, cool, yeah. Yeah, because I guess the Russians, they were quite ahead in the space race back in the 50s, weren't they? They had some of like the first, I can't remember which lunar mission it was, but they had the first picture of the far side, for instance, didn't they, I think?
Yeah, I'm trying to remember which lunar one that was. No. I'm not going to guess a number because it'll probably be wrong. Less than 10. One of the single digit lunar missions, I think.
Yeah. But I suppose one of the reasons maybe why some of these return samples aren't discussed as much is, I guess, it's in terms of amount of material that was collected, it's a lot less compared to the Apollo, isn't it, I suppose?
Yeah, so Lunar 24 collected the most, and that was I think just shy of about 170 grams. So I think in total it's a couple of 100 grams across the 3 missions that they managed to collect. So yeah, in terms of Apollo samples, yeah, just on a different scale.
Yeah, because I guess so. Apollo, I can't remember the exact number. I don't know if you remember, Sam. It's like 400 and something odd kilos, isn't it?
Yeah, it's in definitely in hundreds of kilograms. Yeah, as opposed to a few hundred grams. There's a big difference.
Yeah. So how much material have we got in the Royal Society collection then?
So that's been part of what we've been trying to do, is to just catalogue what's left. So originally they received about 0.5 gram of Lunar 16 and Lunar 20, and a similar amount of Lunar 24 samples, but from different depths within the core. So yeah, part of what I've been doing is just to try and get a grasp on what's still left, because obviously some of the original analysis that was done and they were allocated to was destructive, so they're just trying to gauge on what we've got left. And equally, is there any sort of sat line about in people's desk drawers that were analysed like back in the 70s, and yeah, trying to track down the collection to make sure it's as complete as possible, because as you said, like globally there's not, you know, if you only had a couple of 100 grams to start with anyway, there's certainly not vast amount of lunar sample left.
Yeah.
So over the past few decades then, where has most of the Royal Society collection been stored, and like who keeps track of this?
So Colin Pillinger was in charge of curating the samples. So whilst he was at Bristol and then at Cambridge and then at the OU, and when he passed away, the Royal Society then gave a grant and transferred the samples to Katie Joy at Manchester. So yeah, that's the current situation of them now.
Okay, so Manchester are going to be in charge of looking after these samples and long term?
Long term, we're still sort of figuring out what the plans are for that and what's going to be best for the collection. And yeah.
But I guess ultimately the goal is that people can easily look up what there is and request material, etc.
Yeah, the idea being, like, at the minute, you know, if we want to put a request in for Apollo samples, we can go and have a look, see what's there, see what try and figure out what we're going to request, and there's like sort of a formal process for doing that. But at the minute, well, previously, these lunar samples was just sort of there. There's some written records of what was there and everything, but there's certainly no database or anywhere that, you know, people could request, you know, I want that subsample and I know what it is because I can see some nice images of it and have a look beforehand and stuff like that. So yeah, the idea being that, you know, John, if you wanted some lunar samples, you could go and have a look on the database, be like, I want, you know, 20153, please. I'll have X number of grams of that, and it'll just make it a much more easier process for hopefully years.
How have they been stored, Sam? I guess they've been here for a long time, so have they been protected from the atmosphere and moisture? And
so they are pristine in the sense of what I guess you sort of very pristine moon rocks are. They're certainly where it's sealed in nitrogen or anything like that. So most of them are just in little glass sample vials, but part of what we've been doing as well is making sure that like all the storage is sort of future proofing it, because I know we had some problems, like even down to if the ones that were in glass vials were great, but we had ones in plastic vials, so you know, in terms of long-term degradation of the sample, plastic isn't ideal. We had other instances where these tiny little glass vials have had the labels wrapped around in sellotape, which 50-year-old sellotape is pretty grim. Like, it is flaky and orange and horrible, which, yeah, it panicked me when I first saw the flakes coming off it, because I was like, oh my God, is the sample leaking out? And I was like, no, wait, that's like orange tape, like it's all good. But in terms of future analysis, you don't want to be like tipping your sample out and half your analysis be like some random sellotape. That was part of what we were doing as well, making sure that they're stored in a safe way, and they're stored in a way again as well that we can just go and look up on a spreadsheet. I want that sample, pick it out of a nice test tube rack, rather than they've been all separated into boxes based on who'd done what previously and who'd sent what back, and it's much more organized now, I think.
So I guess you've had a lot of old documents to sift through and stuff. Has that been quite challenging? I can't imagine. Or has record keeping been generally quite good, or is it been quite patchy over the decades?
Is that there's generally quite a lot of the like lab notebooks and everything were really useful to sort of like get initial weights and like see what's been done with the samples. But as you can imagine, there's been certain instances where you're trying to follow a trail and then there's just nothing mentioned, and it's like, where did that sample go? Who did what with it? And sort of tracking those things down has been it's been quite interesting. And as I say, it's just tricky to keep on top of it, because you're like, I think I've seen that in like one of the hundreds of scanned documents that the Royal Society has, and trying to piece it all together has been interesting. But that was another part of it as well, working out what has previously been done on the samples, because as an example, like some had like magnetic separation and density separations, that like they'd be useful things to know for people requesting these samples in the future, so that they know what to expect with their analysis, and that it's not going to affect that in any way.
Yeah. So have they been fairly extensively studied then, would you say, or have they not really been looked at that much?
I think there's definitely like when the initial allocations were made, like a lot of, I think for each time, both of the sort of the 16 and 20 samples were analysed first, and then the Royal Society got some more Lunar 24 afterwards. And they've definitely, there's two sort of like special editions of the Royal Society.
Okay.
One of their journals where it was sort of like a big, this is all we've done. And they've certainly done a lot there, but obviously with the advances and what we can do now, it was like there was two peaks of like first allocation of Lunar 1620, then Lunar 24, and then it's sort of tailed a bit. So I think there's definitely scope to, there's sample left, and there's lots of different things we can do now. And I definitely think it's an avenue for the UK lunar science community to sort of
pick up again.
Yeah.
I mean, I think it's I don't know. I'm certainly very guilty of just sort of putting those missions in the back of my mind and sort of forgetting they're really a thing. They could potentially be really important, I guess.
Yeah, it's been really fun to learn about them. Yeah.
Which is odd, because like you said, John, Russia or Roscosmos were ahead in a lot of things compared to NASA in a lot of different things. Do you think it is just because USA had the big headline of first man on the moon, that's why that's the main things that we remember?
I don't know. I guess it's probably also just the sheer volume of rock they brought back, isn't it? I guess it's much easier to study big lumps and stuff when you've got nice thin sections of basalts, rather than just, I mean, I guess a lot of the lunar samples, they're soil samples, aren't they, Sam?
Yes, it's all there's some larger fragments, like bigger than a millimeter, but otherwise it's just soil fractions of sieved to various different sizes.
Because I guess because I think NASA have some, don't they? But isn't it difficult for Americans to request? I don't think they can request material from Russia directly, can they?
I'm not quite sure on as you say, how it works in terms of sample requests, but I know initially NASA did sort of like
they did a swap,
some Apollo samples for lunar samples, but I guess sort of ease of access potentially as well. I suppose that comes in turn with having more sample, you can do more.
So unfortunately, I guess it comes down to politics, doesn't it, about different nations working or not working together.
So other than like doing the cataloguing side and maybe working out where different bits of samples ended up, were there any other like bits of information that you had to collect about the samples for this, like, you know, database you've put together?
We did some other than, yeah, I guess generic things, sort of like getting sample weights, because we transferred some samples, as say, from the plastic into new glass vials. So whilst we did that, we weighed them, collected images of all the samples. So yeah, there's that sort of bank and database that people can access. And then again, yeah, just tracking down links to papers and things that sort of people, as you say, could go on a database and just sort of like a one-stop shop of what they need to know about that particular sample. But yeah, other than that, it was just, yeah, trying to get all that information and just have it in one place that was sort of easy to access.
Yeah, no, this is a really interesting conversation to have, because I know you've been working on this for about a year now, isn't it?
Yeah, started, yeah, about a year. I think I started on the 1st of February last year.
And yeah, I know you've been in the clean labs, the clean suit a lot, but I didn't realize this is what you were doing. So
yeah, that's what I was doing, taking pictures of tiny little bits of the moon.
So I suppose a logical step next is, you know, where can people find all this information you've put together?
That's a very good question, and unfortunately, my very like non-helpful answer is that we're still trying to figure out what the best way of getting this, as I say, somewhere that either people can request access to it or it can be made available to. And we have to. I know we touched on it with the sort of like who can learn what, and you know, there's all sort of that side of things that. Yeah, way above me to work out what the deal is with that. But yeah, hopefully, at least now that this is done, that's sort of like one of the big hurdles into actually having them conversations. And, you know, now we can be like, here's the database of your samples. This is what there is. Like, how do we go about the next steps? Which, yeah, hopefully would be in the not so distant future. It would be really cool if
well, it sounds like a huge task.
Yeah, it
so
was it was quite it was fun though, like, you know, you're getting to look and unearth samples that people haven't looked at for like nearly 50 years for some of them since they've been last looked at, which is quite fun.
In terms of that next step as to what happens with this, is that just a conversation with the Royal Society, or, you know, are different like universities or research groups involved with that?
So at the minute we've been mostly in contact with the Royal Society, with Keith Moore down at the Royal Society. But yeah, I guess in the future, I imagine, as what happened when they first got these samples, there'll be some sort of a committee set up, similarly to how they request Apollo samples, but obviously not on that big of a scale. But just to make sure that the requests are reasonable, and I guess it'll be important, especially given that, you know, there isn't an awful lot of material in terms of comparison to Apollo. So yeah, it'll be definitely, I think there'll be a committee in the future. Who's that's made up of, not sure yet, but hopefully.
Yeah, every chip counts, I guess.
It does. I was super nervous, especially when we was like transferring like the ones out the plastic into the new glass vials. I was like, oh god, it's like don't sneeze now. That would be like
Don't get sellotape in it.
Yeah. Well, part of all my time in the clean room as well was we wanted to make sure that obviously they like a lot of the stuff now, it's been 50 years, like it's got some like historical value to it. So like even the old sample labels, we would ask different people about like what's the best way to like get paper off, and like there's a whole different world of like different glues for paper and acid-free paper that I didn't even know existed. So yeah, I spent a lot of time slowly peeling sellotape off and then slowly peeling these old paper labels off. So all them are stored now in sort of like archival quality.
That's really cool.
Yeah.
That's like, yeah, all the sort of like art restoration and sort of curation type stuff, isn't it? It's really awesome.
Yeah, because it's something that I've not even thought about, but yeah, having seen the state of like as I say, the sellotape and some of the labels and things, it's worth thinking about.
Yeah, I can't imagine when Colin Pillinger was writing out some of these labels or whatnot, he thought that they'd be preserved in such meticulous detail 50 years on.
Yeah, somebody sat in a clean room 50 years later peeling them off.
That's pretty cool. I guess it might be good just to sort of touch back on to why these are so important in terms, because I guess a question people might ask is, well, we've got all this material from Apollo. What does a couple extra grams from this location really what's that adding to our knowledge of the moon? So I guess it'd be useful, I guess, to point out that these are from a sort of a chemically different region of the moon, aren't they?
Yeah, so especially like I think the Lunar 20 samples, that's like in terms of Highland material, I think that was really useful for showing some of the like heterogeneities in the Highland material, because we'd only sampled like Apollo stuff before in the what was it, PTK. Right.
Yeah,
I was trying to like, spell it out in my head to make sure I'd got the letters right.
But I guess for the audience, I suppose you've got most of the Apollo missions that take place in sort of central area, in these areas that are enriched in iron and titanium, well, not titanium, but like rare earths and thorium and stuff. Hence the term prosolarium creep terrain, I guess.
PKT and that's
yeah. Whereas
I was about to say, oh no, what does PTK mean? And should I know what it means?
But yeah, but it's I guess it's the fact that the Apollo samples are from a chemically anomalous area of the moon, and I guess I can't. So the lunar samples, I can't quite remember. I guess, are they just on the edge or they're outside of this area? So they may be more representative of what, say, the far side is like, and they're perhaps a bit more sort of directly comparable. So maybe some of the Chang'e samples and stuff like that. Is that fair to say?
Yeah. So like, yeah, they're just outside, and the sort of Mare Crisium is Lunar 24, and then a bit further south you got Lunar 20, and then Lunar 16 is in Fecunditatis under, yeah. So that the sort of in a like an almost vertical line right along the eastern edge of the near side. Yeah, so completely different, as you say, to where Apollo samples were collected from. So yeah, it was like your sort of first chance to sort of compare what, as you say, we've got tons of the Apollo sample, but how representative of the full moon is that?
Yeah.
I had another question. So the recent Chinese sample return mission to the moon used robotic technology, and these lunar missions used robotic technology as well. But how did they compare? There was a huge time gap. Were they similar?
So yeah, the Lunar 16 and 20, I think, used quite a simplistic, like a drill core, straight in, took the sample, and then that was it. That's all it did whilst it was there. Once it had done packaged up, and that came back. Lunar 24 drill was a bit different. A similar premise. You've got a length of drill core, it drills in, but there's some quite cool images of like, I've seen it like called like the sample snail, or like it looks like a big Cumberland sausage, because like the tube was it was sort of like almost like encased in like a bag, so it was a flexible tube, so that they sort of wound it round a drum to return it like that, which was quite cool. But yeah, I imagined, I don't know much about the Chang'e drills that they're using at the minute, but yeah, I imagine it's probably progressed a bit since the time of the lunar missions. But yeah, I know that the Lunar 20 didn't get as much, like in terms of like sample weight. It was, I think it was probably only about 50 grams from Lunar 20 because the regolith it wasn't as consolidated as they thought in that region. So yeah, they didn't get as much out with that drill. But yeah, I imagine that as I say, in terms of sample mass, there's certainly a lot more sample being brought back on robotic missions with the Chang'e 5 samples and stuff than these. Oh, we've still, the other thing that's quite cool, we've still got like the original canisters that they were delivered to the UK in, which they're quite cool. They come in a little box and it's got some like Russian on the top.
That's cool. Yeah, I guess. I mean, did the Russians send much documentation about what they were and where they were and all that kind of stuff? Because I guess it must link into the main mass that Russia keeps.
Yeah, they got ideas of like depths and stuff from where they're from, and yeah, I think that mainly for Lunar 24, they've got multiple. We've got multiple different depths.
Yeah, because I mean, as from the UK, are we able to request Russian material, or is that politically insensitive as well?
I'm not even sure. Yeah, I'm not.
Because I mean, I guess they must have. Obviously, they got. I assume they have the main mass, but you rarely see papers about this, do you?
Yeah, because there's something that we've been thinking about is like, in terms of who's eligible to still use the Royal Society samples and what permissions and stuff we need for them. Yeah, it's tricky. Yeah,
it seems like a bit of a minefield.
I have a basic question. Like, of the amount that was gifted to the Royal Society, how much have you managed to like account for? Either like, what we have in Manchester or what has ended up in different labs across the place?
Yeah, I think about I'd say about 50% is still sort of we've still got, or we know like that it was used for analysis, but it's still sort of good to go for future analysis. Like it was used for like mineralogy or petrology. Like there's still main sample masses there, but yeah, there's I think at the time probably about 30% I think was used for destructive analysis, and then you've got some sample, about 10% sample loss from just subsection in the samples. And then there's a small proportion that we've still got to try and track down. Yeah, either what happened to them, like did they get were they part of some destructive analysis? Are they still sort of distributed out? Was they returned and things like that?
The back of someone's filing cabinet.
Yeah. That part of it has been trying to sort of, as you say, get a grasp of sort of what are we looking at in terms of what we've still got, it seems a good time to sort of do a sort of stock check of what we're expecting to be there and potentially where the rest might be.
Absolutely. I mean, it seems to me that this is going to be a really important resource moving forward. I think it's going to be such a useful package when it's all sort of up and live and stuff. So I'm really excited to have a browse through, see what cool science ideas we can come up with. Yeah,
that's the whole thing. We've got this resource, like and I think that the Royal Society probably echoes that that it is something that might as well as make use of, given sort of things that we can analyze and stuff now. It seems it's doing a disservice to it just been sort of stored in some drawers.
Absolutely. I think my philosophy in terms of Lunar samples is that they're no good sat on a shelf. We should be using them, we should be analysing. If we run out, then we'll just have to go and get some more, won't we?
But so even though the work with the database and chatting to the Royal Society about what you're going to do with the samples is still ongoing, if people do want to find out more about all the information you've gathered, I believe that you've got an article out recently.
Yeah, so we've got an article out in ANG, Astronomy and Geophysics. I I think 50 years of lunar legacy without the R. So yeah, if people want to go and have a look and get
pop a link in the episode description. And it's an excellent article. It's really turned out brilliantly.
Yeah,
so a must read.
Did a great job of all the graphics and stuff as well. Made it look really nice for us. So, but yeah, that's got a lot more information about, like, if people are interested, where the samples got allocated to initially back in the 70s and stuff, and what was done on them there, and some papers pointing to their analysis and stuff. It's all detailed there, and there's some cool images of, like, some of the original sample stuff, and some of the updates that we've done.
Amazing. Well, thank you, Sam. I mean, obviously we've had you on for previous episodes to, like, talk about PhD research, which has been, doing the analysis, maybe the destructive stuff on samples. How has it been, like, doing a bit more of a behind the scenes curation role?
It's been really cool. Yeah, there's, like, a whole different side to, like, samples and sample curation and stuff that, like, I was oblivious to. As I say, just look online, this is a sample that you want, put in a request, and the sample magically arrives, and, like, I didn't really give a second thought of how much effort goes into the fact that there's got to be documentation, and how important it is that you can trace what you've done to a sample, because you might have somebody 50 years down the line trying to figure it out again. But yeah, it's been really exciting, and it's been fun to, as I say, work on lunar samples that I didn't really even have an appreciation of whilst I was working on Apollo samples. So yeah, it's been really exciting.
Fantastic.
Amazing. Well, on that note, I think that's all we have time for today. So thank you very much, Sam, for coming on again. Hopefully we'll chat to you for a 4th or 5th installment. We'll see. And yes, for anyone listening at home, all the links to our social media will be in the episode description and on the end card, and we'll pop a link to Sam's new article in the episode description as well. So yeah, thanks everyone for joining, and we will see you soon.
Bye, everyone. Thanks, Sam.
Thank you.